Hello, folks. How's everybody doing? Got a little throat trouble now. So, we have a big day today. Long day. Hope my throat clears. First, I want to remind everyone we have a conference, the 8th Rational Physics Conference in Lusaka, Zambia. And we've been around. We've been in Austria. We've been here in Germany, Frankfurt, Germany. We've been in Scotland and Mexico and Argentina. And if anyone wants to host or prepare, or, the next conference, please contact us. You can contact us here at tokakaka@hotmail.com. Okay. And if that's the case, we'll announce it at we'll be glad to announce it at the Zambia conference, okay? That's first thing. The other thing is I uploaded the book, okay, known as The Rope Hypothesis, brings you up to speed on the rope model of light and gravity. You can find it at ropehypothesis.com. Look under books. Okay, you'll find it's a free book. You can download it. It's about, about 160 pages. And it'll bring you up to speed on what the rope model is about, what this channel in large part is about. Okay, I got to begin today with an apology. Today I was going to talk about good old Aristotle, and I was going to talk about Euclid and infinite planes, but some things took precedence. Turns out several people had questions on some of the foundations of what we call physics, okay? And it's not the physics done by the establishment, which is something called mathematical physics, and which we claim has nothing at all to do with science. Nothing at all. So what's the issue? The issue is that these people criticized several points. They said, what do you mean you don't do observations? What do you mean you don't do experiments? What do you mean you don't use math? And yeah, we don't use any of those. We don't verify, we don't make predictions. What do you do? If you don't do any of those, what do you do? We do explanations. That's what science is about. Science is about rational explanations. We want a rational explanation. If it's not rational, then we don't care what the explanation is. It belongs to religion. Okay, that's how simple it is. You might say, well, rational is your opinion. No, we've defined the word rational, just like we define all words, all critical words. We define what science is, what physics is, what philosophy is, what rational means, what exist means, what an object is. We define all those words very precisely. And yeah, the criteria, there's several criteria. I'm just going to mention a couple. For what is rational, what is a rational theory? You cannot move concepts around. Specifically, none of the concepts of mathematical physics. You cannot move around, claim to be moving around abstract concepts such as energy, mass, force, time, charge, or field. Famous 6 words of mathematical physics. All those words are 4-letter words as far as we're concerned. They don't belong not only in science, but much less in physics. Okay, so because these folks had questions about these things which people take for granted, that's what they learned in high school or in college. Today I had to address that issue. More so because I had a little debate, a little discussion with a gentleman during that past week involving what I call physics, or the foundations of physics. That's what it came down to. It had to do with gravity. Okay. The fellow goes by the name of Ed, and so I'm going to talk about Mr. Ed. He was questioning specifically the issue of whether experiments have anything to do with physics. Okay, that's what he thinks has to do something with physics. I'm saying experiments have nothing at all to do with physics. So how did it start? Well, it started with him asking if I could explain why two objects of different weights, right? You have an elephant and a feather. Well, not a feather. Feather's a bad example. An elephant and a rock, right? The elephant weighs a little more than a rock, a little stone. You let him go, and barring any, we know from an experiment on the moon, barring any friction, right, and any other interference, the two objects fall to the ground at the same time. And he says, can you explain it? And I said, yeah, I can explain it. And so I explained it to him, and he said, oh, but you didn't explain it. You didn't explain the mechanism. I said, huh? I thought I did. In fact, what I did, I pointed him to a picture that illustrates what I was saying. All he needed to do was look at the picture and understand the mechanism. But here he says that I have not explained it. And I could not understand why he could not understand it. And so I said, well, what was it that you did not understand of the mechanism? He said, well, you made an assumption. Okay, and yeah, you made an assumption, a supposition. What you did was make-believe. And, I said, well, do I get points taken off the test because of this? I mean, yeah, I do make an assumption. It's required of the scientific method to make an assumption about the invisible entities that Mother Nature uses out there to do her daily stuff like gravity and magnetism, because they're invisible, intangible. They are obviously untouchable, unhearable, untastable, unsmellable. So you can't determine them, you can't determine their nature through any kind of experiment. You can only do it with the mind. Well, he didn't understand this. He said, oh, but you did not use real entities. And so we got a problem here. Imagine, I'll give you, for instance, an example here. Ship capsizes, right? And a buddy and you're the only survivors. You end up on an island. So you're eating coconuts, that's all there is there. And it turns out this fellow, he's a country bumpkin. He's never been to the city. But he's watched movies, and so he says, Bill, I've seen those cars running on the streets. He's never seen a car out there in the country, right? But I've seen them on the movies. And I've always wondered, how is it that those cars run? What makes them move forward? Magic. I don't know how they do it. And I said, well, let me explain to you how they move, how a car moves forward. And he says, you can explain it? Sure, I can explain to you how a car moves forward. He says, okay, let's see. And I say, imagine it has an engine in there. But you're not doing a real explanation. I wanted a real scenario. I want a real explanation. You're using an assumption. Well, yeah, I need to use an assumption for you to understand how the car moves forward. But that's not real. Because an engine is not real. An engine does not exist. So how does a car move forward? Well, the car moves forward because of a force. See, when we're in the country, we put the donkey, and the donkey pushes the cart, and that's the force. Okay, and so he says, a force is a thing, but an engine is not, is a concept. And I'm trying to explain that the engine is what drives the car forward, and he's saying, but that's an assumption. That doesn't exist. That was his argument I'm exaggerating here, but that is essentially the argument that this fellow made. And the reason he's got that idea, he calls himself an experimental philosopher. Whoa. In fact, he was almost offended. I called him a physicist, okay, yeah, or whatever I called him. Okay, so here it goes. This is how the dialogue went, okay? He asks, the blues are all going to be his, the red ones are going to be mine, okay? It may well be that the theorist, okay, must make a hypothesis. But I am not a theorist. Oh, sorry to have confused you. I'm an experimental philosopher, okay, who is studying natural phenomena from scratch. One who wants an explanation, not a hypothesis. So I try to give him an explanation, and this is the answer I get. Okay, so what was my answer? The first one, I want to address the issue of philosophy, because we had a little bit of debate as well over there in our group in Facebook, and we have the my good friends, one of them is the one who's hosting the conference in Zambia, Shamu and Dave, and they also believe that I'm misusing the word philosophy, and a lot of people do. And the problem is no one has ever defined the word philosophy. That's the problem. Nobody knows what philosophy is. And here you have the first few that I found on the internet, if you just Google it, you'll find things of this nature. Philosophy is a way of thinking about the world. That's one definition. Another one says philosophy is a set of ideals, beliefs used to describe behavior. And he mentions Buddhism as an example. Another one says philosophy is a science of what? Of existence. He says metaphysics, which is one of the branches, deals with existence. I thought physics was the science of existence. I thought physics studies that which exists and tries to explain and identify what exists. And here they put that under metaphysics, which falls under philosophy. And then you keep going. Ideas about knowledge, right and wrong. Huh? Is this about morality? What is this? Is this about religion? About what you have to learn in church? Whether it's right or wrong to kill an animal? What is this about? And it says ideas about how to do something or how to live. Like, live and let live. That's my philosophy. So it's a recommendation. It's an opinion. Is that what philosophy is? Wikipedia says it's the love of wisdom, comes from days of the Greeks, right? The study of general and fundamental questions about existence, again, knowledge, values, reason, mind, anything. It's a jack of all trades. Philosophy is everything. Whatever you study, it's philosophy. Love of wisdom. I guess that means you have to sleep with the wise sage of your tribe. Is that what wisdom is? And I like the Catholic Encyclopedia best. It says, the list of conceptions and definitions might be indefinitely prolonged. Yeah, but what I liked about it, they did finally, the fellow who wrote that article says, zeroed in on why, on purpose and reason, which is what we say is philosophy. Purpose and reason, okay? What is philosophy? Philosophy, we had to define it because no one did in the last 3,000 years. Since the days of the Greeks, no one has a definition, not only of philosophy, of physics or of science. No one knows what science is, no one knows what physics is, no one knows what philosophy is. All the definitions are nonsense out there, okay? And they all contradict each other. This guy says this and that guy says that. So we don't have a definition after so many hundreds of years, if not thousands of years, okay? So here we had to cut through the crap and say, look, this is what science is. Science, rational explanation. You have an irrational explanation, it's not part of science. I don't care how much math you got behind it, how many experiments. If you have an irrational explanation, if you move concepts around one of them, if you don't define your terms or use them inconsistently, if your theory doesn't follow from your assumptions, from the hypothesis, if you claim to have explained and you only described, there's a whole bunch of criteria, series of criteria that we've defined for what is rational. Now we can use that word rational. And the other one is that's explanation, not descriptions. Math can only describe. So math is not a part of science because math can only describe. And people don't understand it. They say, oh, but tradition, and this is what my teacher told me, authority. We don't care. We don't care how many people vote for your definition. It's not a question of voting. You got to get inside the ring and fight for your definition. And that was the argument I had against my two friends there, because I said philosophy has not been defined. We need to define what philosophy means and is. You go to the Stanford Encyclopedia of Philosophy, and not a single article survives. It's all nonsense. It's all idiocy. It's all opinion. If that's what philosophy is, and what the hell, what do we need philosophy for? Everybody's got his own philosophy. No, if we're going to use the word philosophy, let it mean something. And that's why, they proposed an alternative word, which has been around for a while, since von Mises, Austrian economist, or philosopher, I guess you could call him, praxeology. And, I disagree with that. We need to get inside the ring and fight for the words. We need to fight for the word physics first. I mean, I could also say, look, I go to the mathematical physicist and say, what you're doing is not physics. What you're doing is mathematics and some irrational interpretation. Well, that's what we call physics. Okay, then I'll show you. I'm going to call what I do X. How's that? And I say, that suits us fine. Go ahead. Go ahead with your X. And so I go around the world and say, look, folks, I'm going to tell you a little bit about X. And everybody's, what the hell is X? No, I got to get inside the ring and steal the word physics away from these people. I got to especially remove that word math out of there. There's no such thing as mathematical physics. There's only physics, and math is math. Math is a language that has nothing to do with physics. Math is a language of descriptions. Physics is what? Explanations. You need to explain a mechanism. You explain them with objects, and you're going to explain causes. What caused something to happen. That's what we do in physics. Philosophy, if it serves any purpose, it's got to be a branch of science. And if it's a branch of science, what does it explain? Because science is rational explanations. Well, what it explains are reasons and purposes. Why someone did something. And these folks said, let's use the word praxeology. Well, they can use it. I'm going to continue fighting in the ring for the word philosophy. I need to get the philosophers out of philosophy. They're not philosophers. They only have opinions. I don't know what a philosopher does. You go study in a university philosophy, I don't know what you studied. Because philosophy is like everything. It's a way of thinking. Yes, your philosophy. That's all it is. It's an opinion. So what the hell is philosophy? What do we need philosophy for? No, philosophy, if it's got to have some meaning, it's got to say what the Catholic Encyclopedia says. It's got to explain purposes and reasons. Now we have a useful purpose for philosophy, okay? So yeah, I'm going to fight for that word. I'm interested in the word philosophy. I'm not interested at all in the word praxeology, okay? Okay. So Mr. Ed continued, and he said the following. Said, I see an apple fall from the tree. Okay. Newton, revisited. I wonder if it falls because it weighs. Okay. Would it fall more slowly if I cut it in half, right? Okay. So I cut it in halves. What do I see? Every half falls as swift as the other one, and as swift as the uncut apple had fallen. In other words, you take half an apple, you take a whole apple, you let them go to the floor, and they both fall at the same time. You say, hold it, this one weighs half as much. Why did they both fall at the same time? That's the question he wants to answer. It's a valid question, okay? I want an explanation of that observation or fact, okay? It is a fact that no theorist, he's already predisposed, okay? It is a fact that no theorist is able to rationally explain the phenomenon of equal free fall. Well, not a theorist, no mathematical physicist can explain that, okay? Let's get that straight. Physicists can explain it. A mathematical physicist cannot. People who graduate from Cambridge and Harvard and all these Ivy League colleges, those people cannot answer these questions, okay? Because anyone who goes to a big name institution goes there not to get an education, not to be a scientist. They go there to meet people who are going to put them in the right places. And the only way you're going to be put in the right place is if you suck up. If you go up there and, I mean, how else are you going to get an advisor for your PhD? Unless you, answer the questions on the test the right way. You know what I mean? You can't buck the trend. Not if you want a job at CERN or at SLAC or at NASA or whatever. Okay? It is a fact that no theorist is able to rationally explain the phenomenon of free fall, of equal free fall. Why then should one expect any rational explanation of anything from a theorist? I don't know what he means by theory, because a theorist is an explainer. So if you're going to give an explanation, you're a theorist whether you like it or not. A theorist is an explainer. Okay, that's what a theorist is. He explains, and that's what a scientist is, as long as he does it rationally. Okay, okay, so well, let me leave this up there. So what did I answer to him? Hope I left the right one here. Yeah. So what do I answer? Well, here's my answer to that. This is the picture I sent him. Okay. I said, look, all you got to do is really look at the picture and you'll understand why two atoms, in this case, two hydrogen atoms to make it simple, fall at the same time, okay, or have the same weight. At a given distance x from the Earth, a hydrogen atom, whether it belongs to an elephant or a feather, they have the same number of electromagnetic ropes converging upon it. In other words, from every atom on Earth, you have a rope that is connected to that atom. Okay, aside from the fact that every atom in the universe is interconnected, but here the Earth is the closest object. Okay, and so the Earth, every atom on Earth that comprises the Earth is connected to that atom, which is at a given distance x from the Earth, or from the center of mass, we could say. And the same for the elephant. So it doesn't matter if the atom belongs to an elephant or to a feather, the atom will fall at the same acceleration. Okay? It'll have the same weight. And it doesn't matter, because one of the things no mathematical physicist has figured out is this the principle of equivalence of Mr. Einstein. Okay? Einstein said you have inertial mass and gravitational mass. And you say, oh, Bill, what the hell is all that? I don't understand any of that. Very simple. I'll explain. 2 seconds. You don't need to go to high school. You don't need to go to the university. This is kindergarten stuff. Okay? Gravitational mass, pull. Inertial mass, push. Is that difficult? That's how simple it is. One is push and the other one's pull. That's what it is, essentially. Okay? You don't need to know any more than that for this. And it doesn't matter if the elephant is flying out of the Earth and the feather falling towards the Earth. The atom, the hydrogen atom, at a given distance from the Earth has the same number of ropes it has to have from every atom in that comprises the Earth attached to it. And as soon as the feather falls 1 inch forward towards the Earth, or the elephant goes farther away 1 inch farther from the Earth, their weight had better change. Like that. There has to be a change. I hate to use the word, and I'm not going to, well, I'll use it. Instantaneous. That's not the correct word, but what changes is the number of ropes, effective ropes, attached to that atom. That's what it is. Farther away, all the ropes come together. They act as one. Closer together, they all fan out, and now you have more ropes. That's why you weigh more the closer you are to Earth, and that's why it's instantaneous. Your weight changes with location. Location is not motion. Location is a static concept. If we could freeze the universe, right? God suddenly moves his magic wand and everything freezes where it is. The number of ropes converging upon that atom there, you can count them. Gazillion. You move it closer to the Earth, it's got gazillion and one. You move it farther away from the Earth, it's got gazillion minus one, or whatever. That's the way it works. That's why gravity is instantaneous. So I sent them a picture, okay? Sent them this picture. And the other thing about it is, if you look to your right there, you'll see weight. What is weight? Weight is a static concept, okay? And what the mathematicians do, they equate Newton's second law of motion, which is that first one there, force equals mass times acceleration. And they equate it to the gravitational mass force, which is force equals the letter G, which is missing there, a constant, doesn't matter. And then they have mass over really distance. The mathematicians use the letter R, which is an error, okay, big error there, but it's distance squared. And these two equations, they say, oh, force here and force there, it's the same thing. No, they're not, because the distance in the gravitational mass equation is not the same distance as the one in the force times mass times acceleration. Okay, the distance is what changes. See, to a mathematician, all he's interested in quantitative stuff. He's not interested in qualitative stuff. So when he measures a table, it doesn't matter to him if it's length or distance. To him, those two words are synonyms. Why? Because he has to unroll the end of the measuring tape to measure the table or the separation between two tables. Okay, so to him it doesn't matter. For physics, we're interested in qualitative stuff. Separation is not the same thing as length, because length is the continuous matter between two surfaces, whereas separation is the absence of matter between two objects. They're not qualitatively the same, and we do not unroll measuring tapes in physics. That's something they do in mathematics called distance traveled, which they confuse with distance. Okay, and the problem here in this equation is that the force in Newton's second law, mass times acceleration, that's distance traveled. That's not distance. And whereas the distance in Newton's general universal law, mass over distance squared, that distance is separation between two objects. Totally different. We're talking about two objects versus the acceleration of one object. And it's a long story, longer story than here. I'm just going with my little brush real quick over that. I've talked about it in the past, but I can talk, and I plan to talk about it in the future, but right now I'm going to just keep going. And here you have why we don't fly out of the earth. That's good for all these flat earthers who believe that the earth is flat. No, the earth is not flat, buddies. The earth is spherical, or more or less, it's oblate, but essentially every atom in your body is attached to every atom on the earth. That's why you don't fly away. And the guy on the other side of the planet, maybe China versus the United States or whatever, he doesn't fly out because every atom in his body is attached to every atom in your body. There you go, right through the earth. All these ropes, they crisscross. And so the earth can go anywhere it wants. It's going to take you along with it because you're tied to the earth. And every time you jump, you are not stretching the ropes for sure. All you're doing is changing your distance and the number of ropes that converge on you momentarily. And then, you know, that when you fall back on the earth, again, they change. Okay. And yeah, it's a different concept altogether. Here's another comment by Mr. Ed. He just continued in the discussion. He said, the rope hypothesis, if there is an explanation of the phenomenon of equal free fall, I didn't find anything relevant. I mean, I show him a picture. I'm just trying to get him to understand the mechanism, and he's saying he didn't find anything relevant, he didn't find any mechanism. He didn't understand it, he didn't read, I don't know what he did. What I found is corroborating my view that it makes no sense to begin an investigation of reality with a hypothesis, idea, theory. See, in the religion of mathematical physics, all these people, what they learn is that a theory is and a hypothesis, these two words are synonyms. A hypothesis is simply an untested or temporary or provisional theory explanation, and now we're going to test it a little more with some kind of experiment, and then we get more people to vote for it. And the more people vote for it, eventually it becomes a fact. That's the way it works in mathematical physics. That's not what a hypothesis is in rational physics. Absolutely not. A hypothesis is an assumption. What is that? Well, here we have it, just so that we can see side by side what it is different. Hypothesis. Mathematicians confuse a hypothesis with a theory. They have been taught by rote and through authority that a hypothesis is a theory that is in its infancy. In science, on the other hand, a hypothesis is defined rationally. Hypothesis includes the objects, definitions, the initial scene or statement of the facts. Hypothesis is a set of assumptions that the theorist must make in order to lay the foundations for the explanation that follows. Okay, you're going to lay the foundations of a theory. That's called a hypothesis. You need to have the objects. First, I need to know what objects are, which ones are going to be the actors. Is it a stone? Is it the window? You're going to tell me how the window broke? I need to know what are the objects. So first you got to point to the objects. And then you got to have definitions. What do you mean by this? What do you mean by that? Basically by the word object, the word exists. Two critical words of physics, okay? And yeah, so the problem with Mr. Ed is he wanted to be convinced. Okay, so let me put that back up here one more time. Okay. So what he was expecting is to be convinced. He wanted me to prove something to him, to twist his arm and convert him and recruit him to my religion. That's not what we do in science. In science, we explain objectively so that the person understands the mechanism. In science, we must explain. In physics, we explain mechanisms. We do so not to prove theories or to get the jurors to believe in them. We explain so that the crowd understands the mechanism proposed. So the reason you didn't find anything relevant regarding the phenomenon of equal free fall is that you were expecting to be persuaded, convinced, converted, and recruited. In physics, we merely explain a mechanism so that the listener understands it. Okay, that's what we do in physics. And he doesn't understand that. He thinks physics is about, that's what he learned in college, that physics or science is about persuading. He thinks it's about preaching to the congregation and saying, let me prove it to you. Here's the evidence. This is the experiment I ran in my lab, and here's the proof so that you should be convinced, be persuaded to join my religion. That's what they do. And so when someone says, no, none of that is science, what we do in science is tell you a mechanism, you believe it, fine, that's your problem. Doesn't concern science. Science, we explain a mechanism objectively. If you're going to explain a mechanism, you need objects. And for the objects, you have to make an assumption. And that doesn't sound too well with them because they're not used to that type of reasoning. Okay? So Mr. Ed continues, and he says, your rope hypothesis is certainly a clever one, but what does it say? It just says that things might well be. It might well be the way you describe them. The question remains how they really are. Said Newton once, I do not investigate how nature might possibly work, but rather I want to know. Big word, know. Nobody's defined knowledge in the last 10,000 years, but he wants to know. Know means belief. According to Plato, justify true belief. No one has defined it since. No one has a good definition. They all have different opinions about what the word know is, but he puts the word know like, you know what I mean by know, don't you? No, I don't. I'm sorry. In fact, I defined the word know, which has nothing to do with science, by the way. That's why I don't put it in there. But I want to know how it really works. Really meaning he's talking about actuality. He's talking about what really exists out there. And so that's what we're going to get into next. And he says, I agree. Throughout your paper, I find the rope hypothesis, the assertion of the rope being a really existing object, used as a means to explain phenomena. The method of demonstration, therefore, is circular. See, this is the problem with atheists, theists, and agnostics. They don't know the scientific method, none of the three. And I used to be an atheist, so I have to apologize. I was just as dumb as they were, so I pardon them, I forgive them. Why are all these people atheists? See, most of the mathematical physicists, I would say the majority, at least, are atheists. And that means they're irrational individuals. They don't know the scientific method. They don't know about science. That's why they're atheists. And the theists are also, well, they're even worse, probably. And then you have the more retarded agnostics. They say, oh, I don't know if God exists or not. I think I'm going to go to the lab and try to run an experiment to see if I can prove the existence of God. And when the experiment remains, indefinite, you say, well, I don't know. I still have my doubts, and I don't know if God exists or not. None of that belongs to science. None of that has anything to do with a scientific method. In science, we don't say, I believe that God exists. I believe in the existence of God. I know God exists. I don't know whether God exists. I know God does not exist. We don't say any of that. In science, we say, let us assume that God exists. Let us assume that God exists. God can only be an assumption. God is not a theory. The theory is, perhaps, how God created the universe. And you have to make an assumption. And the assumption is God. So this is the issue here. The issue here is, he says, the rope being a really existing object. Well, in order to know if it's a real existing object for the purposes of an explanation of a mechanism, all we have to do is define the word exist. Then we'll know if it's a real existing object. Okay? And of course, we define exist, real, actuality. All those words, they mean the same. They're synonyms in physics, in science. And we define it as an object that has location. If God wants to exist for the purposes of a theory, of an explanation, if God wants to exist, that means he's going to form part of the hypothesis, of the assumptions, right? God wants to exist, he has to have two properties, two attributes. One, he's got to be an object. So the question you got to ask a theist is not, what is God? No, that's not the question. The question you got to ask him, is God an object or is God a concept? Does God have shape or does God not have shape? If God does not have shape, God is a concept and you're praying to a concept. And I hope that concept has an ear and has good hearing, you know. And if he's an object, if God is an object, that doesn't make him exist. God has to have another condition. He's got to have distance with my chest. There better be a straight line of direction between his head and my head. God can hide in the 26th dimension for all I care. There better be a straight line of direction from God to me. Then he exists, by definition. Not because I believe, don't believe, or maybe I believe, or I don't know if I believe. It's got nothing to do with belief because there's no provision for belief or knowledge in the definition of the word exist. All right. And so this was my answer to him. If you understood the mechanism, okay, proposed for gravity, we're done. I mean, if you looked at the mechanism and you understood it, we're done. I'm not asking you to believe in it. I'm asking you to understand it. I achieved my goal. Whether you believe it and it's been proven to you, that is your personal opinion and doesn't concern science. If instead you did not understand the mechanism of gravity, then you should ask for clarification. But to make a vague statement regarding not finding anything relevant amounts to, well, trolling. That's what it is. He's a troll. All you had to do was look at the picture. You have two choices, dear Ed. You either state precisely in your own words what you understood or didn't of whatever you read, or you challenge the mechanism exposed in a rational and explicit manner. Okay? So that was my answer. He's got to tell me what he didn't understand. He can't just say, well, you didn't put anything relevant in there. Well, I don't know what you read. I don't know if you even saw the pictures. I mean, what was there to read? One paragraph? I mean, I don't know. Maybe he's got a Twitter mind, one-liners. That's all you can read. I don't know. So he continues in this debate, and I'm taking snapshots, so I can't put it all out there. What is your rope? It is a concept. Okay, not an object. Here's my famous rope. Take it to all my conferences. This is a concept? I thought it looks like an object to me. I mean, I can draw a rope. And if you don't believe me, I mean, you can go on the internet and look up the word rope, Google rope, and see if you get any pictures. Or go to the hardware store and ask, the man there and say, could you give me a 2-strand rope? Hopefully it gives you something in your hand to take back with you. Okay, and instead, this guy is going to say that, and hold on, I got to hold on to say this. He says that force is a physical object. You'll see that in a second. It is a concept, not an object. There is no such thing in nature. What the hell is that? There's no such thing in nature, he says. What the hell? It is fiction generated as a product of the smart mind of Bill Gates only. Oh my God. So we got a problem right there. He doesn't think that a rope is a physical object. We got a serious problem there. And so what do I answer? I say, well, A rope, any rope, whether here on Earth or on Mars or in the land of the Klingons, has shape. That's the key point. An object is that which has shape. The word rope, always without exception, refers to that which has shape anywhere in the universe. Shape is the only universal attribute of objects. But if you know of a rope that doesn't have shape, please bring it to the conference. Only then can we confirm your claim that a rope is a concept. Otherwise, he's got to define what an object is and what a concept is. And he did give it his best shot, poor guy. He gave the word object his best shot. And that also blew my mind. Okay? So he continued, and he says, nonsense, a rope hypothesis is a concept. Now he changed the argument. He said it was the hypothesis that is a concept, because as a hypothesis, it comes from within. A force being experienced as something real outside is an object. He actually said this. He says a force is an object, but a rope. But of course, he changed the argument. He said it's the hypothesis, which is the concept. Well, I know a hypothesis is a concept, but a rope is an object. But he never addressed that. But instead, he made it worse. He just said that a force is an object. Now we really have a problem, because this person doesn't understand the difference between objects and concept. He thinks love is a physical object. He thinks a heart is a concept. I thought it was the other way around, at least, you know. Okay, so what does he do with this concept called force? He does miracles with it. He says an apple falls to the earth. Why? Good question. Why? Is there a rope connecting the apple to something distant? The experimental philosopher, that's him, right, finds out by taking the apple in his palm, he feels that the apple somehow pushed against his palm. Okay, by something unknown. No rope here. Yeah, you don't see the rope, right? You can't touch it, because an object is not that which you can touch or see. An object is that which has shape. So if the experimental philosopher is expecting to see and touch, you know, with his eyes and his hands and his ears and his mouth and his nose, well, he's going to run into trouble, because Mother Nature specifically made the rope invisible and untouchable. So you can't approach it through an experiment. Experimental philosopher? No, the only way you can approach it is through the mind. You can only visualize it, because you're trying to visualize the mechanism. That's what you're trying to visualize, not the rope. You're trying to see how Mother Nature's doing her tricks. Okay? The experimental philosopher calls the unknown something that locally makes the apple heavy against the palm by the name weight. Others call it gravity. And again, it's these people who believe that weight is equal to Newton's second law, which is mass times, in this case, acceleration. This specific gravitation acceleration is the acceleration of gravity here on Earth. That's what the G stands for. And that's not true. Weight is not equal to mass times gravitational, the gravitational G, okay, the little g there, which is 9.8 meters per second squared. That's not weight. Weight is a static concept. It's location specific. Okay, so this is what he's saying. He says, I hold the apple, in this case the ball, right, in my hand, and I have all these particles hitting on it. Okay, that's what he's going to be thinking about. Okay, and I put the ether behind it, just because this is what these people are thinking, that there's some kind of body of particles in the universe that somehow is pressing the apple against his hand. That's what he's got in mind. Okay, and so Ed continues. Give me a second here and put him up there. And he says, because right now he's holding it. He's holding the apple, right, or the ball, right? Now he's going to move it. Now he opens his palm, okay? The apple falls to the ground, okay? The apple now falls. What is the cause of that motion? Good question. Do not feign a hypothetical pulling rope. Still no rope here, and no pull. He knows for sure there's no pull, that it's all push. And he says it, the cause of the apple's motion cannot be seen. Can't see it, but he's trying to do it experimentally. The experimental philosopher calls that cause a force, which is obviously an object in his mind, which is just another word for cause. That's the cause, the force. What pushed the cart is the force, not the farmer. Okay, which is just another word for cause. Okay, evidently this force is not a hypothetical concept, but a real entity. So he thinks that force is an entity, a thing, an object, a body, or whatever he thinks an object is, a thing is. It can be identified by the really observable effect, motion, it really generates. So he's trying to figure out what in other words, he comes to the notion of force indirectly by watching something that he can see and touch, and he says, well, something moved it. I'll call that a force. And it's got to be an object because it caused that effect, so it's got to be an object. On the other hand, my robe, that's not an object, that's a concept. That's an assumption, that's make-believe, that's a supposition. So none of that has anything to do with his version of, experimental philosophy. This force can be identified in the same way as when a stone comes through your window. So now force is a stone. See, he treats it like a physical object, just like the relativists treat time as a physical object and say they warp time. Same thing. Then they deny it. Then they say, no, that's not what I meant. You misunderstood. You got to take math to understand what I said. Okay, through your window from the outside, we always know in mathematical physics that it must have been thrown. He's talking about push. Okay? That is, there must have been a cause outside generating the motion of the stone. Okay, so what is he saying? He's saying this. He's saying, from the experience of push, because push is the only force that exists in mathematical physics. They don't have pull at all. The experimenter knows. No, they always know. Okay, the force of push is proportional to the generated motion. Double the push, double the velocity, etc. He also knows. They always know. If you repeatedly push something, its motion grows swifter and swifter. Analogously, the velocity of the falling apple, which accelerates in the course of fall, must be caused by a succession of pushes in time. All this guy ever learned is push, and that's all that mathematical physicists have ever learned, and that's why they use particles, because that's what they use to push. Those invisible ether particles, that's what pushes. Okay? So this is the only way they understand it. They understand it as a push. They never understand it as a pull. And so here, this is how he visualizes this. Okay, he says here's the particle, and it's being pushed by particles coming down. So here you have this ball. It's being pushed by particles, and there have to be ever more particles pushing on it because the ball accelerates towards the Earth. The gravitation is an acceleration, so it's got to have more and more particles pushing it as time goes by. Okay. So that's never been explained with particles, okay? So what I say is, well, what if we make a new assumption? Instead of particles, we pull. And we pull right through the hand when it's standing still, when the ball is standing still. That's why he feels pressure on the hand, because it's being pulled right through his hand, okay? And why does it fall when he takes his hand away? Well, here we have it, okay? You see what's happening. Every atom of the ball is connected to every atom on Earth, including the horse. And as it falls, the ropes fan out. And so there are more effective ropes. And therefore, therefore you have the explanation for acceleration. What do we mean by effective ropes? Well, here's a picture of it. Okay. Let me get back in here. Okay. You have two objects, cylinder and a cube, okay, whatever box. And you have atoms 1, 2, 3, 4, and 5 in the same axis on the same axis in line with number 6, which is from the other object. As the cylinder moves closer, the ropes fan out, and now each one acts independently. We call those independent ropes that were not independent in the first case. We call those effective ropes. Now we have more effective ropes as the two objects approach each other. Notice we didn't create matter out of thin air, what we did is change the distance, which is what Newton's equation says. You change the distance, you change the force, which is not a force really. In the case of gravitation, it's known as tension. But they never learned that either, and they think that tension is a force. Okay, so here we have it, okay. You see three guys, Andy, Charlie, and Bob. This is in the book, by the way. And you have Charlie holding the center of the rope that these two guys are, tugging. And let's say Andy is tugging from Bob at a force, or really a tension, but we'll call it a force, no problem. Force of 10x, whatever x is, we don't care. We're in the land of the Klingons. They have a different measuring system over there, so we got 10x. Can Charlie pull at 10x strength or force, both from Andy and from Bob at the same time? No. If he pulls from Andy, he's favoring Bob, and if he pulls from Bob, he's favoring Andy. The only way he can pull on both or not pull on either is by simply being the center and being irrelevant. Here, Andy and Bob are pulling on each other, and Charlie could be inexistent as far as they're concerned. The only way we notice Charlie's presence if he steps aside from outside of the axis. Now he's pulling a 10x from each one of these guys. Now you feel his presence. When he was in the center, he can't pull from both guys, and so it's as if he wasn't there at all. And that's the issue with the atoms. Here you have atoms A, C, and B, and C is inexistent. It doesn't exist for all practical purposes because you don't feel its weight, its mass, its whatever. All A feels is B. The only way we're going to feel C is if it steps out of line. Then we feel it. You can do this with a rubber band. You can, not because it stretches, but to get the sense of what I'm talking. If someone just holds the center of a rubber band while you're pulling it apart, I think I have one here. Okay, you pull a rubber band, okay, and someone holds the center, you don't feel his hand. The only way you're going to feel his hand is when he pushes it out. Then you're going to feel his tug. Then you're going to feel his presence. Okay, that's what it's about. That's what effective ropes relates to. Okay, so you can prove this to yourself, proof, evidence in your own dark basement. Okay, and so here is the synthesis of that. You have Newton's gravitational equation, which has nothing to do with force. It only has to do with tension, and tension is not a force. Force, someone wins the tug of war, whether it's push or pull. Tension, no one wins the tug of war. There's a big difference. And the mathematicians never figured that out. They think tension is a force because they think of something like, a rubber band being stretched to the limit or something. And so what does that equation tell us? It tells us that there's two objects, object one and object two, and they're separated. That's what it is. And the farther they are away, the closer the ropes get to each other. In other words, the more they merge. And you can see at the bottom what happens. When they're close together, the ropes fan out. When they're farther apart, they act like a single coaxial. That's what effective ropes means, and that explains the mechanism of gravity right there. You need to know more than that. Do you believe it? That's your problem. That's totally your problem. I'm explaining a mechanism. Whether you believe it or not, that's your personal business. That's your religion. I mean, I don't care. It doesn't concern science. Okay, so that's when Mr. Ed, he changed his tune a little bit, right? Right, perhaps the apple could be tugged. For the first time, he pondered that possibility. It kind of clicked on, oh, yeah, it could be tugged. It doesn't have to be pushed. Maybe it's pulled right through the hand. Or perhaps not. Who knows? Knows. I don't care about knows. We make an assumption to understand the mechanism, and he's talking about knowledge. Provided that there would be something pulling, if this is really the case, nobody knows. This is not a question of knowledge. This is a question of assumptions. You have to make an assumption about the invisible entities that Mother Nature uses to do gravity, magnetism, light, all these invisible, tricks that she does. You need to make an assumption. You can't go to the lab and say, oh, I'm going to see if I can see it or touch it. And even if you run an experiment, you're going to deduce it indirectly. You're going to see something visible and touchable. And you're going to say, well, then something moved it, or something affected it, or something was in contact with it. Well, you got to identify that something. And they say, well, I don't see it, and it's not real because I got to imagine it. And so they don't think it's an object because they can't touch it or see it, and they have to imagine it. They say it's an abstract or a spiritual object. No, it's an invisible, untouchable, intangible object. That's what it is. All objects that Mother Nature uses, all mediators that she uses, are invisible and intangible. Now imagine Mother Nature would have made air visible. I mean, Mother Nature, God, and Father Universe, all three of them got together with the devil, all four of them at the bar, and they said, look, okay, we're going to make some people dumb. we're going to make some people, what is it, experimental philosophers, but we can't make them all blind. And if we make air visible, then that's all they would see. You would see air at all times in front of your eyes. So they, in their smart way, fortunately they were not like these experimental philosophers. They said, no, in our wise wisdom, right, love of wisdom, we're going to make air invisible. And that suits us fine because now we can see. And likewise, if Mother Nature made the rope that binds any two atoms visible and tangible, everything would be tied in knots. So she was they, all four of them, including the devil, they were smart. They said, look, in our wise wisdom, what we're going to do is make them invisible and intangible. That way no one gets tripped when he walks and no one gets tied up in knots. So they are invisible, intangible, insmellable, inhearable, intastable. They have all the ins and outs. You can't touch a rope. You can't determine this through an experiment. That's why experiments have nothing to do with science. In science, you got to sit back and theorize. That's what science is. You got to give me a rational explanation for that mechanism. And this goes over their heads because this is not what they've been taught in school by rote and through authority. Okay, so here when you say, well, where'd you get this thing that atoms go right through your hand, stick out? Here we have Professor Richard Muller of Berkeley University. He says, for example, if you have the Earth, there's a big mass here, and you can see the mass, the big M, that's the Earth, big mass. And you have you with your little mass here. Every atom on Earth is pulling on every atom of you. You're also pulling on it. The amazing thing about gravity is that it goes right through things. So why did I put the ropes coming out of the hand, right, connected to the ball right through my hand? Because that's exactly what he's described there. Every atom is pulling on you, you're pulling on it. Gravity goes through things. And, at least Mr. Ed was able to figure something out. He was at least a little wise here. And he says, note that the amazing thing about gravity is that it does not go through things. Correct. Because it is already there. He doesn't even know what he said there. He hasn't read his own sentence. It is already there. Keep that in mind. By experience, it exists already everywhere in space. So it must not go from a source to a place where to act on the gravitating body. But he's using a push force, surely made of particles in his mind, and he's saying it pushes. The ball is pushed, or the apple is pushed against his hand. But he's saying it doesn't go anywhere. He's aware of that. He knows that it's already there. It doesn't move. It doesn't go through things. It doesn't move through things because it's already there. What else could it be if it's already connected? If every atom is already connected, it doesn't have to go. Of course, he's totally right. Gravity is not a motion thing because weight is a static concept. Okay, and so here's the illustration of that. I've got that in my book, and here you have, interconnected atoms. There you have it. It's already there. We're not throwing balls that move through the air to produce gravity. No, gravity is a tug because the ropes are all connected. All atoms in the universe are interconnected, and they go right through things because they're already there, as he well said. So, what can I say? Give me a second here. So what do we have for Mr. Ed? Well, I think Mr. Ed's not really a horse. I think he's a mule. I've been talking to a mule all these days, I think, What can I say? These are the people who run the world. They sometimes complain about their colleagues. They say, oh, you're retarded. Look, you believe in space-time, in black holes, in Big Bang. And they believe in bigger nonsense. So yeah, I think I wasn't talking to a horse, I was talking to a mule. What can I say? These people don't understand the scientific method. That's what it's all about. They run with this scientific method that they developed in the 17th century, people like Galileo and Newton, and they say, oh, experiments, that we need experiments and equations. That's science. And it turns out equations and experiments have nothing at all to do with science. No, in science we have to explain. That's where you have to break your brain. And I always give the example, you go to the show and you watch the magician cut the lady in half, 2 pieces. Curtains closed, curtains open, and here girl comes out, ta-da, 1 piece. In this universe. In another universe, I guess that she's cut in half. That's the explanation a mathematical physicist would give you. But, so you ask the mathematician next to you, you say, how did he do that? And the guy says, oh, I can tell you perfectly. Oh, okay. How do you do it? Well, he took a saw and he cut the lady in 2 pieces. And it took 10 strokes of the saw, and he did it in 15 seconds. That's how he did it. I was trying to ask how he did the trick. I don't want a numerical nonsense measurement saying, oh, the acceleration of gravity is 9.8 meters per second square. That doesn't tell me what gravity is. Specifically, it doesn't tell me why the Earth doesn't fly out of the solar system. I need a physical interpretation for that phenomenon. And the phenomenon is that the sun twirls the Earth around itself because every atom of the sun is connected to every atom that makes up the Earth. Now we can understand gravity because, and why the Earth goes more or less in a circle or ellipse, whatever, around the sun, because it's physically bound to the sun. And we can also explain the elliptical orbit because the sun is moving around the Milky Way, and obviously when the cowboy running on his horse around the circle moves his lasso around, that lasso also stretches, and that's why it's not a perfect circle. And why doesn't the moon fly out of the Earth? Because of the same reason. Every atom that comprises the moon is tied to every atom comprising the Earth. The Earth swings the moon around itself. Now, do you believe that there are ropes, electromagnetic ropes? I didn't ask you to believe. I'm asking you to understand the mechanism of how mechanism, cause, the moon doesn't fly out of the solar system. Do you understand the mechanism that I'm proposing? If you do, we're done. We're finished with science. Now you can believe whatever you want. If you don't, then you got to ask me a question of, what it is that you didn't understand of that mechanism. Here I usually use the, where is it? Here. Yeah. Okay. So this is why the Earth doesn't fly out of the solar system. And this is why the moon doesn't fly out of the solar system. Because it better be physically bound to every atom on Earth, or else in that region, you're putting spirits. You're doing gravity with spirits. If you don't put anything between the Earth and the moon. And you say, well, I can't see anything. I can't touch anything. There's nothing there. The astronaut goes out there. He doesn't touch anything. Hopefully, because Mother Nature made all objects that she uses, all mediators, invisible and intangible. Does that mean they're not objects? Does that mean they're not real? Well, for that we need to define the word object and the word real. That's what we need to do before we begin the discussion. The word object, that which has shape. Does this little thread have shape? This would be the ropes, representing the ropes. Does a rope have shape? Yeah, here it is. Here's a rope. It has shape. So we met the condition of object. What does it mean if we say that it exists? It has to have location. And that's a big can of worms, but we'll deal with that next time. Anyways, we'll see you on Wednesday, and hopefully I can get back to the subject matter that I was covering. We'll see you then. Bye-bye.